Now we will want to find the area of the regions, and here they're kind of having two graphs. Find the area shared by r equal 1. R equal 1, I know what that looked like. That's really this circle. I am on the rim of that circle right there. And r equal twice the cosine of theta. We said sine is the y, positive 2. It's a circle wrapped around the positive y-axis with a diameter of 2. And which region are they talking about when they say shared? Isn't this the shared region between both? No matter how I do this problem, I need to know what this point is, because that's the point that's breaking up two different sectors for me. Now I'm going to show you what happened if I zoom in on this graph. If I take this graph and I enlarge it, there it is, much better. If I look at this graph, do you notice that area is going to be the integral? Now from 0 to this angle that I got right there, from 0, I don't know what that is, it's going to be 1/2 of what? Do you see that I'm only running to the circle, and the circle is twice the sine of theta squared d theta, plus the integral from whatever that angle is, and I'm going to run to pi over 2. And do you see, once I pass that red angle, I am really running to the green. And how am I going to find that? Well, I'm going to take the two graphs and set them equal to each other. That's when sine of theta equals 1/2. What is the reference angle? Sine of which angle equals 1/2? If you remember, theta must be pi over 6, right? So this is pi over 6, this is pi over 6, and there it is. And this is going to get me the right half. All what I have to do is take this quantity, multiply it by 2, and that does the trick. So the graph is extremely important for visually seeing what region you're talking about, and solving is a must. That was the big deal of trigonometry. That was the big deal of why you need to take trig before you could actually tackle this. And if I get to this problem, I'm looking at, oh, I need one more. That's okay, I could alter that slightly. This is 2 plus 2 the cosine of theta. I'm going to go up 2 units. This is r equal 2. And I'm going to move the amplitude 2 units above and 2 units below. If I am at 2 and I move 2 units above, that's r equal 4. 2 units below, that's r equals 0. Graph of a cosine starts on the amplitude. And there it is. This is 2 pi. This is pi. This is pi over 2. Since r is always positive, there's no inner loop. And cosine positive, this graph is wrapped around the positive x-axis because cosine is positive. Something like that. At 0, I am at 4. At 0, I am at, I'm going to say this is 4, this is 2. Decreases. By the time I hit pi over 2, there's pi over 2. I am at 2. There's 2. So decreases. Looks like this. Keeps on decreasing. By the time I hit pi, I am at 0. There's pi and there's 0. And I know the right symmetry. There it is. Similarly, I'm going to sketch the other graph. And the other graph looks very much like it, right? If I look at this graph, that is 2 minus 2 the cosine of theta. That's still going to go up. Let me just fix that. I am going to go up. That's cosine of theta. Twice the cosine of theta. I'm going to go up 2 units. That is r equal 2. And I am going to move 2 units above and 2 units below. So the graphing is all done in the previous section. That's why we spent so much time on it. 0 and 4. Except this one starts reflected. So since this is x and it's all positive, there's no inner loop, and it's going to be wrapped around the negative x-axis, so the heart shape looks more like this. This is 2 pi. This is pi. This is pi over 2. At 0, I am at 0. Increases. By the time I hit pi over 2, I am at 2. There's pi over 2 and there's 2. Keeps on increasing. By the time I hit pi, I am at 4. There's pi, 2, 4. And by symmetry, I could get the bottom part of the graph, and there it is. And we want to find the area that's shaded by both. There it is. Now I could use symmetry on this, but I'm going to assume it's not symmetric so that if you come across it and it's not symmetric, you don't know how to do it. I'm going to take this, and since we have to use more space anyways, I'm going to enlarge it a bit so you could see it better. Oh, come on. So observe how this works. Area is going to be the integral, and let's see. I run from 0. Do you see I'm running to the green? So from 0 all the way to pi over 2. Again, I could stop there and use symmetry, but I'm not going to do that. And which graph is the green? The green is 2 minus 2, the cosine of theta, right? Plus the integral from pi over 2. Do you see from pi over 2 and on, I'm going to run to the purple all the way to pi? That's going to be 1/2. And the purple is actually 2 plus 2 cosine of theta. And since I have 2 of those, I'm going to multiply the whole thing. You know what? I keep on doing the same thing. Let me put some space. There we go. I'm going to multiply the whole thing by 2. Now, of course, you could just use this and multiply it by 4 because these are symmetric. I'm making the assumption that this is not symmetric, and this way you could do any graph, not just that one. And if I get to this problem, it says inside of this circle, r equals 6. 1, 2, 3, 4, 5, 6. Oh boy, let me see if I can mimic that. That would be awesome. There it is, I got it. And so it says inside, all of the inside, and above the line, r equal 3 over the sine of theta. R sine of theta equal 3. This is y equal 3. So if I go to y equal 3, y equal 1, 2, 3, and draw a horizontal line, they're talking about inside of the circle, above of the line. Well, let's see how that's going to play. This is symmetric. I'm going to find half of it. So, and multiply it by 2. We're going to say we need to know what this point is. We're going to say area is the integral from whatever that is to pi over 2. Right? And we're going to take 1/2, and let's see how this works. If I run my arrow, do you see that the tip is the red? I'm sorry, tip is the blue. The tip is the blue. Minus, do you see that the base of the arrow is going to be always the red? And what's the red? And I'm going to multiply that by 2. That part I know. The problem happens, I need to know where those two intersect. Where does 6 equal 3, the cosecant of theta? That's when 6 equal, that's when, might as well, I have time. That's, if I divide by 2, that's when 2 equal cosecant of theta. If you don't know where that is, that's okay. Cross multiply. And where does the sine of theta equal 1/2? Again, in case you've forgotten, that's an ugly triangle. But with the time, 1, 2, radical 3. The sine of which angle? The sine of 30 degrees. But I need to use pi radians. So this is from pi over 6 to pi over 2 multiplied by 2. And that's how it's done. I have one last example for you guys. I'd like to find the area of the inner loop of this graph. Actually, no matter what I ask about this graph, you need to figure out where the area of the loop happens. So I'm going to start with 2, 1, 2. I'm going to move my amplitude, which is 1, 2, 3, 4. If I am starting at r equal 2, and I should label that clearly for my graph, I am at 6. And if I move 1, 2, 3, 4 below, I am at -2. And we know from the previous section that this is going to have an inner loop. A graph of a cosine starts on the amplitude, runs down to the amplitude, back to the starting point. There it is. This is 2 pi. This is pi. This is pi over 2. And this is 3 pi over 2. So, again, I'm going to use different colors to indicate. At 0, actually, let me go with blue. At 0, I am at 6. At 0, I am at 1, 2, 3, 4, 5, 6. And it seems decreases. By the time I hit pi over 2, r equal 2, there's pi over 2, and there's 1, 2. And this decreases. There it is. Now, I know that this is the graph that's wrapped around the positive x-axis. And since r switches from positive to negative, I know there's an inner loop in there. Right. Now, I am going on decreases. I hit 0 before I hit pi. Somewhere between pi over 2 and pi, I hit 0. This is going to zero out. I need to figure out where that is. Set this equal to 0 and solve it. Where does 2 plus 4, the cosine of theta, equals 0? That's when the cosine of theta equals -1/2. The reference angle is pi over 3. Again, look at the previous problem and look at the triangle. And where's cosine negative? In quadrants 2 and in quadrant 3. That's 2 pi over 3 and 4 pi over 3. I got it. 2 pi over 3 and 4 pi over 3. So this hits 0 by the time you hit that angle. And then what happens? Now, this inner loop starts tracing between 2 pi over 3. So I just figured out that this here is 2 pi over 3 and this is 4 pi over 3. Excuse me. Decreases. By the time I hit pi, r equal -2. There's pi and there's -1, -2 from this angle right there. So from here, it's going to pick up and trace. Basically, I'm done because this graph's symmetric, but I'm going to continue it on just to show you how it's done. And if I go by from pi to 4 pi over 3, from pi to 4 pi over 3, since r is negative, I'm not in this quadrant. I am in quadrant 1. By the time I hit 4 pi over 3, I am at 0. Comes back, and before you reach this, it hits 0. And then it starts tracing between 4 pi over 3 and 3 pi over 2, between 4 pi over 3 and 2 pi over 3. It is in this quadrant. By the time you hit 3 pi over 2, you are at 2. This is 3 pi over 2, and this is 1, 2. There it is. And then it continues on until you get it. I would like to find the area. Now, no matter what I ask, you have to do this work. I want to find this area. Well, can't I say this area happened to be, isn't this area the integral? Don't you start tracing this from 2 pi over 3 from right there? You start tracing this from 2 pi over 3 to pi. Doesn't that run to the actual graph? 2 plus 4, the cosine of theta squared d theta. And since I have 2 of them, I multiply that by 2. And there it is. And that would be my answer. Alright? And there's your homework. I do want you to go on the previous section and do number 25 and 27, find the area.